welcome to the Virtual Lens Summit. This is, I think, the fifth or sixth edition. Every week it seems to grow a little bit, and we're really happy to, sort of unusual this time, we're having it hosted from Germany. You guys are in Freiburg?
Yes.
Yeah, Freiburg, Germany. It's amazing how this technology is working. We have Viola. Evang. How do you pronounce your last name?
My last name? It's Evang.
Evang and David Kellermann. And they're going to be introducing their new lenses, their Vista Vision 2X full frame anamorphic lenses, the Glaswerk 1 and 1 Plus.
Exactly.
Thanks a lot for coming. We've got about almost 150 people on right now, which is pretty exciting. Take it away.
Yeah, thank you very much for the introduction, and thank you for hosting this event. It's a great opportunity for everyone, I think, to make the best out of this situation. So as you already said, David and I, we are based in Southwest Germany, and our lenses are full frame anamorphic lenses. And so we have a small presentation now. And after that, we will be open to answer questions. And we also have one of our optical engineers in the meeting, Christoph Horneber. So if there are any highly technical questions, he can help us with technical specifications. So maybe Christoph, you want to introduce yourself with a few sentences, so you can unmute yourself. Or perfect.
I'm here. Thank you. Thank you very much. Yeah, for me it's also a pleasure to be around with you. Very exciting to talk in front of so many people. Hope we're going to talk about interesting stuff. As Viola said, I'm one of the optical designers. I think my colleague Claudia and Bernd, who did that with me, are also around in this talk here somewhere. So I'm not the only one. We are a company of several optical designers who are supporting Glaswerk in this great lens and in the complete series of that great lens. Yeah,
thank you. So I'll mute everyone so that we don't have any noises around.
Also, we're going to record the sessions so that Michael can put the session later online for everyone who couldn't join the Virtual Lens Summit or live sessions.
So I will.
Okay, so maybe a little bit about the history of the company. Probably why a lot of you haven't heard of Glaswerk so far. Glaswerk, we announced the company officially last summer at the Synergy Expo in Los Angeles.
The audio's not very good.
Sorry, maybe I have to
David.
share.
Viola's audio is really good.
Can you hear me now? Okay, wonderful. So we introduced the company, announced it officially last summer at the Synergy Expo in Los Angeles. But obviously we started the company way earlier. So Viola and I was working in the film industry for quite some time now, and we ran a small rental in Freiburg. And one of our customers had once this very specific idea for a project that he needed anamorphic lenses, but obviously the budget was always quite small. It was a final project for a film university, and he asked if we could build something for him out of old projection glass. And we told him, like, no, it's not possible. I mean, theoretically it's possible, but all those solutions on the market, they don't really work. You have image shift and so many more technical issues. But it was like quite insisting over half a year or so. He said, okay, we accept him, and he brought over a box with old projection glass. So, okay, we put it all together, and as we expected, it didn't work. But the idea was interesting. So I started doing some research about optics, about anamorphics, the history of anamorphics, the different systems. And after a couple of weeks, we thought maybe it's not possible for us per se to build it in our office, but maybe we could build something like a proper lens based on those existing optics, which led us to contact ISCO Schneider, which bought ISCO, since ISCO built, in our opinion, some of the best projection glass out there. The idea was to use the last series they ever made of thin projection lenses with attached Anamorphic attachments. 1 second, I'm bringing the lens. So maybe some of you who worked in theaters in late 90s, early 2000s know those attachments. Blue anodized, quite rare. In my opinion, probably the best anamorphic attachments ever manufactured. But and our idea was to build a variable adopter, basically a focusing group, and get from Schneider, who owns ISCO now, those glass elements and build a proper mechanical housing. But there were obviously a couple of issues. First of all, it's quite large. That's just the anamorphic part. It's only Super 35 and so on and so on. It doesn't work for wide angle. It doesn't really work for longer focal lengths. Anyway, we needed optical designers. And at that point, probably the project would have been dead if not a friend of mine who's building machine vision cameras told me about a company that he highly recommended. So we contacted that company, and the owner told us that this project sounds quite interesting. Okay, I'm coming a little bit closer to the microphone. 1 second, I'm putting this away. Okay, we tested the audio earlier, but obviously not enough. Is it okay now? Wonderful. So, yeah, we got this contact from a friend of mine who's building those machine vision cameras, and he recommended a company, Emma Photonic, as wonderful technicians. We contacted the owner and said, yeah, well, that sounds like a very interesting project for us, because we do have a couple of highly skilled, highly experienced optical designers. We also have quite a lot of knowledge and about photographic lenses, since some of them were working for Leica. Well, wonderful. And that's basically how we started working together with Christoph and Bernd and Claudia, also today in the meeting. And again, like in the beginning, we thought we can do something just like a focus group or something existing, but after just a couple of weeks, we realized that it wouldn't work. So we decided to build the whole thing from scratch. And that was like more than 3 years, 3.5 years ago nearly. So since then we started, first of all, finding a certain kind of design principles. And we tried to find something unique on the market. But my colleague will tell you more about the different aspects in our presentation.
Yes, I will share my screen to the presentation. So when we were in the position that we could actually define the look and say what the lens should look like, we said obviously it should be ready for full frame, because more and more full frame cameras were about to be released or were already announced. So our lens covers Vista Vision, and yeah, like Alexa LF, Red Monstro, Sony Venice, Canon C500 is the new full frame camera by Canon, I think. Yeah.
Mark II.
So we, for the design, we said it should cover 25 by 2.54 centimeters.
So at the time, the Alexa 65 was already announced, and we assumed strongly that Ari will also announce a full frame camera. And since the Alexa LF, Alexa 65 had a sensor height of 25.58, I think, millimeter. Yeah, everyone knows the reasons for that. Slightly larger than regular Vista Vision or full frame. We assumed that the full frame camera that ARRI might bring out in the future will have the same sensor height, so we find that as the height of our image. And for a classic cinema scope, would be an aspect ratio of 1 to 2.39, basically 1 to 2.4. So we took the 25.56 millimeter times 1.2, which leads us to an image width of 30.76 millimeters. So it's not really an image circle because it's an anamorphic lens, but in short, it will cover Alexa and everything with a smaller sensor. So all Sony Venice and other full frame cameras.
Yeah. So we will have an overview about the coverage in the next slide. So for the bokeh, it was very important for us that the bokeh is perfectly oval shaped. So I think with a spherical lens, it's the cat eye effect that the bokeh gets bent towards the corners. With anamorphic lenses, I think it looks even more weird when the tops are cut off of the bokeh. So we made some simulations that the bokeh always gets the shape, and we will show you later how we achieved it. So with some more info about it. Yeah, resolution, it was important for us that you can kind of use it like a spherical lens, so you can place objects on the side of the frame without the faces being distorted or without a total loss of resolution, but still not having strong micro contrast. So they have a pleasing overall resolution across the entire field of view without a super high center sharpness, because that usually leads to lower performance in the corners. Yeah, also for the flare version, it was a bit difficult. We talked to many rental houses and DOPs before and asked them, do you want flares? And if yes, which color should they have? And it was 50% yes, we want flares, and 50% was no, absolutely no flares. And then again, it was 50% for blue flares and 50% for white flares. And yeah, and yeah, so we said we will have two versions. We will explain later how we made it, how we designed it, what we thought about it. But yeah, basically the flare version is what most people prefer so far.
Can you mute it?
Yeah.
Just have to, there are some new people joined us, so we want to mute everyone again. We just have to figure out how it works.
Manage participants.
Oh yeah.
Mute all. Yeah, wonderful. Okay.
Okay. So, aspect ratio. Obviously, normally if you shoot anamorphic, you end up with an aspect ratio of 1.1 to 2.4, 2.39, 2.35, something like this. But there are, of course, also other, wait, there's something up, okay. Other aspect ratios, famously revived now by Tarantino for The Hateful Eight, like Ultra Panavision. And people asked us, okay, why did we design the lens as a 2x anamorphic when modern sensors are already slightly wider than the classic 35 frame? Basically for that reason, two reasons. First of all, we wanted to make the lens as classic as possible, and for us, classic anamorphic is 2x. The other reason is if you use a 2x anamorphic on an Alexa LF open gate, you end up with an image roughly aspect ratio 1 to 2.9. Sony Venice 3 to 1. The shot that you're seeing right now was shot open gate on an Alexa LF 4.5K by the great cinematographer Peyton. I think he also joined us today. Last year after Cine Gear, our first prototype. And the outer frame is open gate. Then there's Ultra Panavision, which is 1 to 2.76. or if you so you just have to crop a little bit to get to that aspect ratio, or you can crop a little bit more to get to classic cinema scope, again, for which the lens is optimized for.
Yeah, so the bokeh is what was very important for us. I already told it in the last at the beginning. So you see in the picture that, so this is a Sony A7 III sensor and it's a still image frame. So we use the entire sensor. And when you see on my cursor, this is roughly cinema scope. So what happens with the bokeh outside of this area here is basically not visible in the cinema scope aspect ratio. But yeah, still you can see that it keeps the performance quite well. Yeah. So this is what we did as a test before we built the lens, to make sure that no lens edges or mechanical parts are in the light path that would cause this deformation or cut off of the bokeh. And yeah, so for example, this is the spot shapes that can appear across the entire range. So this is quite in the center. And this, for example, is the upper right corner. And yeah, so we could make sure in the upper right corner, it looks a bit odd, but it's basically out of the sensor. Okay.
There's some music in the background. Sorry for that.
Someone's having a party on the street.
Yeah. Yeah.
Okay, so we have to close the window because someone is having a party outdoor. I don't know. So the next topic is distortion and MTF, and yeah, so this was shot in a documentary, in a reenactment scene of the documentary Miss Holocaust Survivor. And yeah, so thank you, Matthias Bolliger, for sending us some frames from some stills from your project. Yeah.
Okay, now let's talk about distortion, which is obviously a big topic for anamorphic lenses. Most vintage anamorphics, or basically all front anamorphics, I mean, you have to, there are front anamorphic systems and rear anamorphic systems. The anamorphic, both of them squeeze the image, but only front anamorphic systems will provide you with an anamorphic look that quite a lot of people desire. Basically, all the cylindrical lens elements have to be in front of the iris to provide a look. So the problem is, if you have those cylindrical lens elements in front of the iris, you will quite often end up with quite a lot of distortion. And one aspect that we tried to achieve was to have relatively low distortion, so that people can able to use our anamorphic lens just like they would use a spherical lens. So even for projects where normally you might not choose an anamorphic lens, this would still be an option. You can see the frame grids here. The black pattern is basically the perfect, would be a perfect grid, and the red one is the distortion caused through our lens. We have a little bit of barrel distortion vertically and a little bit of pin cushion horizontally, which basically disappears for Super 35. For Super 35, you can just like cut off the two fields on the left and on the right and on the top. The left one is for infinity, the right one for 1 meter, which is like 3 feet. So the distortion doesn't really change when focusing. So how does that translate to filming? For example, if you frame an actor or actress and then pan away, you don't have to worry that the face of the actor or actress gets kind of weird or distorted, even on the wider focal lengths. So for illumination, the other aspect is that quite a lot of both spherical and anamorphic lenses have lots of light fall off towards the edge of the frame. which is partially connected to the cat eye-shaped bokeh that Viola was talking about earlier. Basically, there are two kinds of vignetting. There's the artificial vignette, when you limit the optical path of the light. You might want to do that because you want to keep the lens small, but you also might want to do it to remove stray light, remove chromatic aberrations, and so on. For us, it was clear that we don't want that, so we have 0% artificial vignette. There's, of course, the relative illumination. The cost, Christoph can probably explain it a little bit better, but it's based on physics. There's always some light loss towards the edge of the frame. If someone is interested in this phenomenon, please ask later during the discussion. I'm sure Christoph can explain that. So, on the next slide, or are there any questions already right now that we should reply to, Viola?
I don't think so.
Okay.
Yeah.
Okay, let's go to questions later on.
Yeah.
So MTF, MTF is modular transfer function. There's always quite a lot of discussion about resolution of a lens. Is it a 4K ready, 8K ready lens, or micro contrast sometimes? So basic resolution and contrast are exactly the same. Micro contrast is slightly different. You can optimize a lens to have like a very high center sharpness with a more of a fall off, and we decided to go for a relatively even resolution throughout the frame. For an anamorphic lens, our lens has a quite high resolution when you compare it to many other, especially vintage lenses. Nonetheless, you can't compare the sharpness to a very high performance modern spherical prime lens, like, for example, signature primes. Or,
yeah, that actually we had an interesting question that someone sent us via mail. It was from Tim Stemann from CrossSeal, and his question was, why do anamorphic lenses look bad on a projector? And I think that's a very funny thing to.
So basically, on a projector, you really see what's wrong or what's right with the lens. So the resolution, which you can see in the Siemens stuff, for example, on a projector, will never be as good on an anamorphic lens as on a really high performance spherical lens. Nonetheless, we try to keep it quite high, as you can see. Again, if someone is interested in the technical details, please ask now or later during the discussion. But kind of what it tells you, those lines, how many line pairs the lens can resolve at a certain contrast. So the top one is 10 line pairs per millimeter, below is 20, and the bottom one is 40 line pairs per millimeter. Sagittal and tangential, both at infinity and 1 meter. So even in close focus, the performance is still quite good. We can focus even closer than 1 meter, down to half a meter, or that's like something below 2 feet. But obviously the performance will go down a little bit in this extreme close focus, especially at the edge of the frame. Another thing that you can see here in the chart, the top one is x-axis, but there's also the y-axis, so the image vertical resolution. We have very little astigmatism, which is quite common on many old or vintage anamorphic lenses. So the top and the bottom part of the frame gets low resolution, mushy. We're using not only horizontal cylindrical lens elements, but also vertical cylindrical lens elements to correct for this. So that's why the resolution is quite sharp. Is there any question right now?
No, don't answer my question.
Okay, I will try my best. But yeah, please let us know if you have any questions about the MTF chart. It's rather technical, but just in the end, our lens is quite high resolution, but still a pleasing image I would say like not as high resolution as some of the modern, very modern spherical optics. So we try to find a balance.
We just got a question from Haluki. MTF charts are only super 35 diagonal correct.
No, they are for the full image field that we defined. So it's from 0 is center to the edge of the frame, which is 15 millimeter. If you go in both directions, that would be 30 millimeter or 30.5, which is, as we said earlier, we used the full Alexa LF, Alexa 65 sensor height, 25.56 millimeter times 1.2 to get a 2.4 aspect ratio. So that's how we end up with an image sensor of, or image field of 30.7 millimeter times 25.5 millimeter. So on the x-axis you have the 30 millimeter, and on the y-axis you have the 25 millimeter.
So it's always starting from 0, from the middle.
Center of the frame.
Yeah. Okay.
Okay.
Mm-hmm.
So, okay, close focus.
Yeah, so we can show it live basically, and then I will probably turn down the red because it's quite noisy, and maybe that's the reason for our sound problems. So I will just switch the camera. 1 second. To this one. So this is basically our close focus.
A little further.
Yeah.
Here.
So here, somewhere here.
Yeah.
Yeah. So this is 52 centimeters below 2 feet, and yeah, basically that's our iris. That's in our 50 millimeter lens. So it has 17 rounded iris plates. That's also a reason why the bokeh is very soft and oval in the background. Yeah. So switch back and reopen the presentation.
Okay, I think we can switch off the background noise reduction. Okay, someone sent me a message that we should turn off the background noise reduction to.
And you just have to turn off this camera and mute it.
Okay. Okay, I'm just trying to speak as loud as I can. And slowly.
Yeah.
Okay, so yeah, just focus.
Yeah, that's basically it.
Okay, flares. Again, as Viola said, when we started asking rental cinematographers, what do you want in an anamorphic lens? 50% said like flares. Yes, we have to have flares. The other 50%, especially European cinematographers, said no, please, no flares. We love anamorphics, but we're really fed up with all those flares. So okay, only option for us to do was to do 2 versions. So we did the one, which is with more controlled flares or no flares, and the 1 Plus, which has some horizontal flares, which you can see here. All the footage that we're showing today is based on our prototype. We did some changes to the prototype, but yeah, it will more or less look that way. Okay, let me just go for the next. So for the flares, we didn't want to experiment until we get a perfect flare. Instead, we wanted to design them in a way. So one of the optical designers is a specialist for flare analytics and straylight. Bernd Hahn, he's also here today, I think. And what we did was, what he did was making a ray tracing model of our lens. You can see that here on the left. And then we got, based on this ray tracing, we received an image, like a simulation, how the flares would look like. So here you see a fully multi-layer coated version of the lens with just here barely noticeable some flares. And that's the flare version, the 1 Plus. On the prototype, we used a single layer coating, which is like the most classic coating available on 4 lens surfaces. The final version only on 3 lens surfaces. And we through the ray tracing simulation, we were able to pick which surface should receive a single layer coating and which surfaces should keep the multi-layer coating, because most flares are not desirable, in our opinion. We just wanted to allow a certain flare. Yeah, and that's how it looks like on the left without any background lighting, on the right with some background lighting. Okay, how do the flares behave? Again, we did a simulation based on those 4 uncoated or single layer coated lens surfaces. When the light hits the sensor straight in the center, and then when the light source, which is now at I think 100 meters away in the simulation, slowly moves towards the edge of the frame. The next one, we can see what happens when you defocus the lens. So the light remains at 100 meter distance to the camera, the simulation. And top left, we see how the flare would look like at close focus, again, half a meter below 2 feet. And to the right bottom part is at infinity. And another very, in my opinion, quite important aspect is the flare color. Everyone desires a different kind of flare, but most people that wanted flares asked us to do them a little bit bluish. So we did a simulation, and we changed in the simulation. We optimized the single layer coating for different wavelengths. Basically, what happens if we do a single layer coating for 600 nanometer or for 650, 700 nanometers, and so on. That's all in the red wavelength area, which means all the red light goes through, and the other end of the visible spectrum, the blue light, gets bounced back, so it creates flares, and you have a blue flare. And how blue does that flare get? Well, that depends on the wavelength of the single layer coating, and you can see that here on the left part on the horseshoe diagram. So
yeah, this is a small spot that was actually shot last week or 2 weeks ago, and Uroš from Slovenia used red infrared pass filter to shoot black and white. And that is really interesting because we corrected for, he was using the plus version, but we corrected most of the flares for the visible spectrum. And yeah, did check for infrared because usually you don't see it. And this is really interesting what happened when he shot with the infrared pass filter.
So the flares are quite more pronounced. Again, that's, all the multi-layer coatings don't really work because they're for the visible light spectrum.
Yeah, so now we have some serious sunlight and some serious flares. Yeah, and in the next slide, I picked the still frame, and the simulation here was actually our simulation what the flares would look like if the lens wouldn't have any coating. And yeah, that's what it looks like with the infrared pass filter. So it's quite similar. This is calculated for full frame, and it is on a Super 35 sensor, so that's why it is cropped a bit. But yeah, you can clearly see that the simulation and reality match quite well.
So when we started talking about our lens at Cinegear and sometimes at events before that, people always told us, yeah, you know, simulations, it's all good, but never turns out the way they simulated. Well, it basically turned out exactly the way we simulated it.
Yeah, so the color. Can show you. Yeah,
wait,
so
we have to switch screen share.
Yeah.
Okay.
Yeah, so this is now a slightly bluish flare.
So we're shooting right now as a webcam using a red with our lens for the One Plus, and that's how the flare looks like.
So color is also there where we want it to be.
Okay, now it's less technical, more about what focal lengths we're going to build, and obviously when we're shipping them so that you can use them. We've been working on those lenses for quite some time now, and the biggest challenge in a way was to define a common design groundwork that will work for all focal lengths. We absolutely wanted to avoid that one focal length looks this way, the next focal length looks another way. So that really took quite a lot of time. But now we finished the 50, we basically finished the 100, the last touches of 32 and 75. So we're shipping this summer, in Q3, the 50 and the 100. Later this year, Q4, the 32, 75. Early next year, 40, 60, 135. And then in the end, the 25 and 100. We said, like, we designed all the lenses for full frame, except for the 25 millimeter. The 25 millimeter would have gotten huge and expensive and super heavy if we designed it for the same performance on full frame. So we decided most people will not use the 25 millimeter on 2x anamorphic on full frame. So we limited it to Super 35. Since the illumination of our lens is quite larger than the specified area, it will still work on full frame, but the performance will not be as good. Starting with 32 millimeter up to 180 millimeter, they're all optimized for full frame, so you don't have to worry about it. And again, 32 millimeter on full frame, that equals like 32 millimeter 2x anamorphic equals 16 millimeter basically, and 16 millimeter full frame equals roughly 11 millimeter on Super 35. So with a 32 millimeter, you will end up with a similar horizontal field of view as regular spherical 11 millimeter on Super 35. There will be we're doing one batch now because just to finish all the focal lengths, and there will be a second batch available end of 21, larger batch. If you have questions about the delivery times and so on, it's probably best if you contact us later, like in the next week by email and so on. We can send you more information, or again now during the discussion. But yeah, we're doing right now those 9 focal lengths. There will be more in the future. There will be something like probably there will be a 300. There will be something like 230, but we haven't started designing those yet. Oh, another quite important thing, they're all T2.4 except for the 180. So there's a constant T-stop on them.
Yeah, so that was actually one question that was asked, the T-stop range, but I think it's already clear.
We don't need those books probably anymore. Maybe we can stop the. Yeah. So again, contact us next week. But now let's start with the discussion. Again, a frame from a shot short film that we shot after Synergy last summer, and yeah.
Yeah, so we have some questions already. So Sean was asking for the T-stop, but I think T2.4 except for the 180 is already set. Then Andy asked if they are assistant friendly. Andy, do you want to unmute yourself and?
Sure. So what I'm asking basically, are the front diameters the same across the focal lengths? Are the gear positionings in the same place so it's easier to do motor swaps and so forth, or lens swaps without having to shift your motors, that kind of stuff?
Yeah, so this will be the same. So front diameter is 114 millimeter, and the size will be, yeah, so the 32, 25, and the longer focal length will be a bit longer than the 50 millimeter. but the iris gears and focus gears will be in the same position, and we'll have almost the same rotation of the, so it's a 300-degree rotation, and the distribution of the focus points
Of the witness
will,
marks.
the witness marks will be the same, except for the close focus range when the lenses differ a bit.
Yeah.
Yeah,
So-
otherwise easy to service, so they can be used
just-
without. Yeah.
So the 40, 50, 60, 75, and 100 have exactly the same size. 32 and 135 have exactly the same size. For the 25 and the 180, we are not 100% sure yet.
So yeah, and the lenses can be used without lubricant. So no matter if it's cold or warm, it will always have the same drag when focusing.
Maybe I will show the lens there on the camera. Let's see, oh, yeah.
Thank you.
Yeah. So all answered, or okay?
Okay.
Yes, that definitely answers my question. Thank you.
Okay. Yeah. So this is the size of the 50 millimeter, 40, 50, 60, 75, and 100.
Can I just jump in and ask, is there a zoom that pairs nicely with these lenses?
Well, not yet. I think.
Yeah.
We can't talk about all the projects for the future. There will be zooms, but I think if you if you don't shoot fully wide open, you can probably use on Super 35 the Cook Anamorphic zoom or the Vantage zooms. I think if you close down a little bit, that should work fine. Or yeah, probably the Panavision Primo Anamorphic zooms might work quite well, because they also have the same slight pincushion distortion horizontally.
Yeah, so one question doesn't have to do with the Glaswerk. It's if we acquired Hans Innotech. No, we have nothing to do with Hans Innotech.
So
So,
we know them as a rental. We did originally with the old company with a rental as a project with them. Didn't work out that well. The cooperation, the joint venture. But this lens project has nothing to do with them.
so another question was if LPL mounts are available. Yes, they are. So standard is PL mount. So we made it work with old film cameras, so that the old ARRI cameras with spinning mirrors can be used. But LPL will be available too upon request. And yeah, we have a cam system, not a helicoid. That's was another question.
Okay, there was, okay. We have to go through quite a lot. Just 1 second. Okay, T-stop T2.4.
And next question, if you wanted to pair another brand lens anamorphic as well for, say, a scene with many cameras or a lighter version on a drone, somewhat similar. Yeah, it's difficult. A lighter version, it's difficult to have a lens with a similar performance that is not rear anamorphic, which has a different look. So,
By Eric asked, are you using existing lenses or starting from scratch? No, we originally was a plan to use existing lenses or existing projector lenses, but we realized that if we want to achieve all those design goals, we couldn't use those. Nonetheless, some of the design ideas stayed from those ISCO units, like cross cylindrical lens elements, or both using horizontal and vertical cylindrical lens elements, like ISCO was using them. That stayed also with our lens. But otherwise, other than those ideas or this inspiration, everything is done from scratch. Again, size, yeah, length and weight. Currently, so the most of the focal lengths have a length of 28 centimeters front to image plane so it's 23 centimeter to the PL mount, and the weight for all of them is roughly 4 kilogram per lens. Some of them a little bit lighter, some a little bit heavier, but yeah, roughly 4 kilogram, which is I think 8 pounds.
So someone asked us how we manage the squeeze factor in the Zoom presentation. Dan, I think. Yeah, we have a red camera with an anamorphic lens, so basically the same setup we have behind us. So the image is already de-squeezed in camera, and then we have an Atom Mini Pro, yeah, to get it into the computer.
Okay. Yes. How long did the process take from the idea of designing lenses to completion? So we haven't shipped the lens yet, so it's not fully complete, or especially we haven't shipped the whole range yet. But we started 4 years ago, roughly, nearly 4 years ago, with starting, like, again, this friend approached us, and we started talking about the design. What could we do? Could we use existing glass? What would we have to do from scratch? Then coming up with those design goals, talking to rentals, finding great optical designers. So yeah, in 3.5, 4 years.
There's this one question, if we had to combine another set with our lenses, what we would choose. Yeah, it's I think it's a question of taste, but some anamorphic lens that has a quite even performance across the entire field, so not a completely vintage lens that has a lot of barrel distortion, but yeah, probably any modern anamorphic lens.
Yeah, most modern anamorphic lenses will do fine. There's the old, obviously the ARRI scopes that not that many people know, which were designed by ISCO. They are the modern ARRI master anamorphics. They're Cook anamorphics. So quite a lot of options, and depends on what works for you, really, how much of a difference you're willing to accept. Obviously, the more modern or larger lens by Panavision, different options. Do the flares change with iris? Yes, if you close the iris down, the flare will change, obviously, as with most lenses. But the base characteristics will stay the same.
Yeah, so are the mounts easily swappable and shimmable? Yes, so it's it can be done in any rental house with a projector. Yeah, that's not. I mean, it is if you shim the lens, it's yeah. Basically.
Yeah, it's the mount there, because we're not using any electronics. Just a couple of screws, and then you can swap the mount. I mean, we're doing LPL and PL for now, and so it's quite easy to change them. The flange depth. So I assume that's about if you can use the lens on film cameras. Yes, one of the first things that we did was contact ARRI to provide them with the technical specifications of the PL mount, like the rear clearance, so that when you use the lens on a spinning mirror camera, it will like clear, it will not hit the mirror. So yeah, it will work on all RE, PL film cameras.
Oh, funny question. Do you grind and polish the optics yourself? No. So it's all done in Germany, Southwest Germany, most of it. We don't say exactly where, but no, we're not doing that. So we are able to assemble the lenses, but we're not grinding and polishing glass.
So we don't have a, like in our office, we don't have the machines or anything. We are using companies that are well established and that are also working for other similar manufacturers like us from Germany. And yeah, same for the mechanics. So, oh yeah, price. Similar price to most modern anamorphics. They are per lens 25,500 euro, which is I think 28,000 US dollars roughly per focal length. That's the price from I think 40 to 100. The 32 and 135 slightly more expensive, 27,500, which is like $30,000. For the 25 and the 180, we don't have the price yet. But again, will be still quite similar to the 32 and the 135.
Any lens data? No, not in this version. So we thought about it, but yeah, the lens would be much more expensive, and it would take much more time to bring it to market. So no, we decided against it.
There's the question, if somebody's in Freiburg, can he look and test these lenses? Yes, of course. I mean, let us know in advance if you're coming, especially right now, due to Corona, it's a little bit difficult. But it's possible, or especially within Europe, if you're quite often at a rental house, let us know which rental, and we can organize to ship a prototype to that rental so that you can test it there. But of course, we can also meet here at our office.
Yeah, so maybe we have some questions left from the emails.
Yeah, so just again, if you would mix them with another set or combine them, again, the Cook Anamorphics, the moderns, the Panavision Primo, they should work fine, in my opinion. It's like, depends on the cinematographer, but I think that's a good option. Okay, questions?
So there was one question, I think it was always asked in the previous meetings, so we prepared a bit for it. It's about the exit pupil of a lens and telecentric design. And yeah, so if our lens is telecentric, it's not, but nearly. And yeah. Maybe Christoph, you can, so we already talked about it, explain why our lens is not absolutely telecentric, but nearly.
Yeah, happy to do so. Telecentric is a really difficult thing to achieve in terms of dimensions of the rear lens. If you have a completely fully telecentric lens, the rear lens must be as large in diameter or even larger than the chip. So you get a massive lens out of it. So of course it's desirable to do so in terms of imaging quality, but you can't really do that in terms of mass and volume. So we had to do a trade-off, and in fact our exit pupil is several centimeters in front of the sensor, which leads to rays that hit the image plane at an angle of 11 degrees of the perpendicular direction. So I would call that nearly telecentric and small.
Yeah, thank you.
There was
special equipment to align the cylindrical optics, one of my favorite questions. So yes, we have special equipment to align the cylindrical optics. it takes, so we have 7 cylindrical lenses, and it takes us 5 minutes to align them. And yeah, so this is what we built when we said we have to assemble and align 7 cylindrical lens elements. We decided to have them all in one block and align the block outside of the lens. So we assemble the cylindrical tower block, put it into our measurement device that was also developed by Christoph and Claudia. And then it takes 5 minutes to align, and then we have the cylindrical tower, the block, put it back into the lens, and we don't have to touch it again. That's really cool, I think. And yeah, so there will be service houses in the world that will have access to this measurement device to that they are able to service the lenses completely without having them sent back to Germany or.
Oh, yeah, that's maybe also for quite a lot of people an interesting or important part. We will have service houses in the US. There will be Duclos definitely in LA. In the UK, True Lens Service, TLS will be a service partner. We're going to add more service houses for the rest of the world. Obviously in Germany we can service them. But yeah, it's like you don't have to ship the lens back to Germany if there is an issue. In general, we designed, we didn't talk that much today about the mechanics, but the mechanics are, I would say, very robust in a way. They're not as super sensitive as some other anamorphics. And if there is an issue, they're quite easy to service. But again, so you don't have to wait for weeks or months until you get your lens back from a service technician. But again, there will be service technicians in all big film areas, so you don't have to worry about the service aspect. There was another question about the availability. So we are doing right now only a small batch, because again, we're a new company. It's just not feasible for us to do like 100 sets, 200 sets right away. We're making 20 sets available right now of purchase. Most of them are already pre-ordered, and those pre-ordered sets will receive, basically as soon as we finish a focal length, they will receive them. Next summer they will have them like the full set exclusive until end of next year, and then end of next year we're going to ship a second batch, which will be 50 sets.
One question about the bokeh from Haluki. What was causing the slightly distorted bokeh in the corner of the field? Just curious. I think you mean the simulation we made. Mm-hmm. And yeah, it's just outside of the specified area. So there can be either the shape of the lens or some mechanical parts. So it was outside of the area we specified for the lens design. So we don't really know what is happening there. Maybe Christoph knows, but it's probably.
Yeah. No, it's quite clear what's happening there. I think Loki means the like slightly banana-shaped image of the bokeh in the corner, and this is because we've got cylindrical lenses in horizontal and vertical direction. So the image is formed at different areas in the lens, and if you go out of focus, you don't have a rotational symmetric image anymore, and then it makes a difference at which position which cylindrical lens is positioned, and in the end it's quite a difficult analysis, but in the end you get this a little bit curved bokeh, but that's only really in the extreme corners. Yeah.
Okay.
Yeah, someone asked again the close focus. That's something that we are really extremely proud of. It's for the 50 millimeter, it's basically half a meter. Then, which is below 2 feet. I'm not sure exactly, but yeah, it's quite below 2 feet. And for the other focal lengths, the close focus will be quite similar. For the 100 it's not locked down yet exactly where we are ending the close focus, but it should be in a similar range. Probably also like 55 centimeters, 60 centimeters, so 2 feet on the 100. So it's basically, compared to other options, it's kind of an anamorphic macro, but all of them.
Okay, so Dan is asking, who was the gentleman with the really cool eyeglasses who was speaking a few minutes ago? I think he means Christoph.
Yeah.
That's our optical engineer.
Thank you for the compliment.
Minimum focus distance is to be announced. Yeah, so the design, we don't have a design lockdown on most focal lengths. We're still optimizing. The 100 start production is basically very soon, but for the others, we are still like tweaking. We're trying to get the most out of them. So we will update the website with all the final, like the data after we lock down the designs. Currently, it's not only Christoph and Claudia and Bernd working on the lenses. We have, after we finished the initial prototype and started based on the feedback, with I wouldn't say redesign, but optimized the original design. We also started working with other optical teams because it's not feasible to do so many focal lengths of so complicated optics in such a short time as only one team or a smaller team. So the other teams, like all teams, are working very closely together. They share the designs, and we make sure that way that all the focal lengths have a very similar look and feel. Oh yeah, any test footage? Yes, we will post later. Maybe you can do it in the chat. A link to a YouTube video that was shot by Peyton last summer on Alexa LF. Also, there is the some pictures on our blog, on our website. We're going to update the website soon. And yeah, we're going to post more and more footage. I think on the blog there are two, on our website there are 2 videos and quite a lot of stills. So how did you achieve this best close focus, Anamorphic?
Secret.
There are different concepts of making anamorphics. Again, we wanted to make a front anamorphic system to get the anamorphic look. And there's a way like, let's say, C-series, E-series Panavision lenses, which use a cylindrical group and then a base lens group, and you focus both of them. And then there's the design, which is a Galilean telescope, in the front, like a spherical group, then the cylindrical lens group, and then again a base lens group. That was, for example, used originally by the Lomo Roundtrons, but it's also used by other manufacturers. That's a concept, and we're using that system. It's basically we're only moving one lens element throughout the whole lens for focusing. So first of all, it's quite robust as a design. So when you shake it, not many things could go wrong because all the other lenses are locked down. And through this design, we're able to achieve this close focus without having any mumps. That's also one thing that we forgot to mention. Most anamorphics, when you focus, have mumps, which is the squeeze ratio changes slightly. So normally, especially in close focus, the squeeze ratio goes down from 2 times to 1.9 or whatever. So when you decrease it later on by 2 times, people look fat, therefore mumps. We have throughout the full focus range squeeze ratio of 2 times, so we have 0% mumps. We still have breathing, so just like other lenses, our lens does breathe. Quite low, from infinity to 1.3 meters, which is like 4 feet. Below 4 feet, down to close focus, there's more breathing, but still the squeeze ratio always stays at 2 times. You mentioned 2 others. Yeah, so Jay asked if the others can also join us. We're keeping right now most the new teams secret for now, for a couple of reasons. But the designers who also worked on the 50 millimeter through Hamburg Photonic, maybe they're also here in the meeting. I hope so. Claudia and Bernd, maybe if you're here, you could say hello.
Yep, hello. Good. Claudia.
Yeah.
Wonderful.
Yeah, so Claudia was also involved in the lens from the beginning. So yeah, she was working a lot on the 50 millimeter.
Yeah, so it's been really Claudia's and Crystal's achievement. And again, Bernd also did quite a lot on it, especially for flares.
Yeah, hello. Here I am.
Okay. Yeah, and for the other teams, we currently still keep them a secret. So, other lenses purchased mainly by rental houses or DPs. So far, they've been purchased only by rental houses, and we also have distributors in Spain and Russia. They also purchased lenses. One reason for that is that they're quite expensive. A set will, in the end, cost $250,000. So so far, only rental houses have bought them. But again, if a cinematographer wants them, of course, feel free to contact us. Barrel distortion or pin cushion. The lenses have vertically a little bit of barrel distortion and horizontally a little bit of pin cushion distortion. I'm not a huge fan of pin cushion distortion, but that was one of the compromises that we had to do during the design process to keep, in general, the distortion very minimal. The wider ones will get the pin cushion distortion, will not get much more extreme. A little bit, the barrel distortion will get a little bit stronger on the wider ones. For the longer focal lengths, the distortion will further decrease. On the 100 millimeter, we basically don't have any distortion anymore. And for basically all focal lengths, when you shoot on Super 35, there is literally no distortion.
So the anamorphic glass comes from, the lenses are shaped in Germany, and the glass is shot or O'Hara. So the glass itself is either from Germany or Japan, but the lenses are made in Germany.
So yeah, I think we went through all the questions. Again, it was great that so many people joined us today. If you have any more questions, or feel free to send us a message. We're on Instagram, Facebook, email. We're more than happy to answer them. Again, there are some secrets that we keep, like our suppliers for the glass and the mechanics, so literally where we manufacture them. And for now, then additional design teams. But with the rest, we're quite open in sharing. And if you want to test them, again, let us know. We can arrange the lens to be shipped to a rental house, or again, you could visit us in Germany, Southwest Germany, and Yeah. So
I mean, maybe we stick around for 5 more minutes, just if any questions come up, we are still here. But yeah, otherwise, thank you for joining us this evening. And yeah, thanks again, Michael, for hosting the event. Yeah.
Michael and the whole Kerner team, thank you so much. We would have loved to join you this year in Portland. Directly, it would have been the first Cylindrical Summit for us. Unfortunately, couldn't.
Yeah, it's too bad. It's too bad. Maybe it'll happen in the future, but it seems like we're getting a lot more reach doing it virtually. And so every Friday, for the time being, we're going to have the Virtual Lens Summit at 10 o'clock Pacific time. Next Friday, we're going to have Creative Solutions bringing Teradek and their solution to streaming. It's sort of a departure. It's not optics, but it's super topical right now in this COVID and post-COVID environment. So it's all about client streaming offsite. And what I say is, finally, we get to do this work without the client present. But and then the following Friday, we have Lindsay Optics debuting their full frame director's finder, optical finder, which is going to be really interesting. So that'll be fun. And then we're getting other exhibitors up, presenters. We're going to have Sigma, we'll have Cook, and I think we'll just go through the whole lineup of all the exhibitors that we're going to be at the regular Lens Summit, and then some. So anyway, thanks a lot for coming. We had a great crowd today, and it was super international.
Wonderful. Again, thank you so much. And we're going to keep the chat open for the next minutes if any questions come up. It was great talking to you, and see you hopefully in at a rental at another exhibition at Kerner in the near future.
David, may I just jump in and ask answer one question that you didn't address? I just saw
Okay, sure.
in the chat before. That was the question: is the lens 4K ready? That was at the very beginning, like 10 minutes after the presentation started, I believe. And from the optics point of view, it's difficult to answer, is it 4K ready? The simple answer is yes, it is. The difficult answer is it depends on the pixel size. So if you, for example, look at the Alexa cameras with a pixel size of 8.25 microns and the given sensor size, our lens, yes, is 4K ready for Alexa. If you're talking about 8K later on, it depends on the pixel size. If the pixel size stays at 8 microns, it doesn't change the performance of the lens, but just the sensor gets bigger. So we would need to see which pixel size we're aiming towards, but for 8 micron pixels, yes, we are ready to have a nice contrast on these kinds of sensors.
Okay. Thank you. Didn't see that question.
Great. There are some new messages.
Oh, one other thing I wanted to add is if anybody has any emails they would like to send me of friends that want to be on the Virtual Lens Summit, they can send it to our email, michael@kernercamera.com or any of the kernercamera.com emails. But I'm all for increasing the community online here, which I think is super fun.
Okay, there was a question by Nick, if there's a minimum order, a down payment. Yes, there's a deposit or down payment of 25%, but we normally do so far only sets for those like initial 20 sets. So you're going to purchase like a 3 or 4 focal length set, and then later when the other focal lengths are shipping early next year, you can basically get a notification, lens is ready, do you want it or not? You don't have to, but you will keep your place in line based on the initial set. So yeah, you should, like the minimum would be like 3 focal lengths, or 3 or 4 focal lengths with 25% down payment. And then for whenever we ship a focal length, the rest of that lens has to be paid. Oh yeah,
das war Michael.
Can you type in what? Okay.
So it was not Jan Wittkop asked we could type in that email.
Oh,
But
yeah,
I think it
Kari
was
Fox. Yeah.
Michael.
Yeah,
Addressed to Michael.
Yeah.
Yeah. Okay. Perfect. Yeah. Mhm. So yeah, is there any question we missed? I don't know
If we missed anyone's question, please write the question again. Oh, there's maybe something last week during the Canon talk, there was quite an interesting question about the usability of the lens in really cold temperature or high temperature. We designed the lens basically without any kind of grease. So if it gets super warm, you don't have to worry about grease getting into the lens. Or when it's super cold, you don't have to worry about the grease getting all sticky and locking the focus or iris. We're using a special kind of peak bearing instead. Also, because there's quite a lot of glass, we have on the 50mm we have 18 lens elements and 16 group. So obviously also quite a lot of metal for the housing. So when it's very cold or very warm, there will be, the lens moves. Every lens will change the performance. But we designed it or calculated that you basically for every 20 degrees Celsius that it gets colder. So we designed it for 20 degrees Celsius, like room temperature. But if it's for every 20 degrees Celsius, you can, like minus, you can take out 75 micron worth of shims. Or if it gets warmer, you can add those shims. And by doing so, the performance will basically stay the same as when you're shooting at 20 degrees Celsius. So normally you don't have to worry about it, but if you're shooting at minus 20 degrees Celsius, like in the freezing Arctic, you have to take out 150 microns worth of shims, and you will still get basically the same performance.
So one more question. A new design not using grease. So for us, it's what we pursued from the beginning, that we don't use any grease. Yeah. I don't know if it's completely new in the industry.
I think others are using something similar. For example, as far as I know, Signature Primes are using something similar. It's just there are different options of different kind of bearings. There are ball bearings, or there are bearings based on peak or similar materials. We are using, instead of ball bearings, we're using peak bearings. Then there's other options that we are currently not sharing. That was one of the reasons why we're not sharing as much information about the mechanics as about the optics, because kind of want to keep it a little bit a secret for now until we ship the lens, what we did, or how we improved, or we try to improve on existing systems. But yeah, it's 150 microns for 40 degrees Celsius, or 75 microns for 20 degrees Celsius.
The device we are using between camera and computer is a Atom Mini Pro.
So the red. Yeah. There was the question. Okay, so the red is de-squeezing the anamorphic image, and then on the HDMI output of the red camera, we connected to the Atom Mini Pro by Blackmagic Design, and that way we were able to switch between the two cameras.
It looks great, guys.
Thank you so much. Do the lens have a linear iris scale? No, they don't have a linear iris scale. So for the focus marks, all the focus marks on the focal lengths have the same distribution, like the witness marks have the same distribution. So both on the 100 and on the 50 is the same degree of rotation to go from 100 meters to 10 meters and so on. For the iris, that's again a compromise. We have 17 iris blades to give you, even if you stop down a perfectly oval bokeh. Downside of having that many iris blades is that it's mechanically basically impossible to have a linear iris scale. So you have the rotation from 2.8 to 4 is larger than from 4 to 5.6 and so on. That was just like, we would have had to reduce the amount of iris blades quite a lot to make the iris linear. Focus throw. Focus throw is 300 degree. And again, same on all focal lengths. So we use existing shims, the size standard ARRI standard shims.
Okay. A question about the lens element, the number of lens elements from Stephen. You mentioned 18 elements in 16 groups. So we have 7 cylindrical lenses, we have 2 aspheric lenses and 2 achromats, and yeah, so 18 lenses in 16 groups. Was this the answer to your question, or?
So you can't really talk about the taking lens. People use taking lenses when they build their own anamorphic lens. So I say you have a photo lens, then you attach an anamorphic attachment, and then you use a Viola diopter, like I don't know, there are a couple of projects on the market to build your own anamorphic. That's when you talk about taking lenses. In this case, we don't have a taking lens. The whole lens is designed as one, so you can't take it apart. I mean, you do get an image if you just use the 8 lens elements that between the cylindrical group and the sensor, like the base part, you would get an image out of that, but you can't focus and it looks all funky. So you have to use basically the whole thing together. It's optimized in itself.
And we have 7 elements, 7 cylindrical elements.
Yeah. So far we are mostly manufacturing for our customers 1+. When a customer orders the lens, they can choose between 1 or 1+. Only difference is that 2 lens elements get a different coating. So if someone wants to go from 1 to 1+, it's not something that everyone can do in the field, but it's possible. You're not locked down, so you could theoretically, if you want to, send your lens back to us or to a service house. You have to purchase those 2 cylindrical lens elements, and they're quite expensive. Unfortunately, they're I think 2,500 per lens, and then they can be like those lens elements can be replaced, and that way you can go from a 1 to a 1+ or vice versa. So the spherical lens is in between those. So basically there are 3 groups in a way, similar to those do-it-yourself anamorphics. You have a front group, a spherical one for focusing. The first 2 lens elements are always in the same place, and the third one moves for focusing. Then we have 7 cylindrical lens elements, and then 8 spherical lens elements. So the cylindrical lens element is in between the 2 spherical groups. No, you can't swap between lens because every lens element is only for a certain focal length. The flare color is bluish, but we designed it in a way to be only slightly bluish. We try to avoid extreme colors because, especially in the future, with HDR becoming more and more crucial or commonly used, if you have highly saturated colors that are extremely bright, both on chromatic aberrations and flares, it will become very distracting with future HDR monitoring. Like when people use HDR 1000 or so, flares will look crazy, like be really distracting. Something that you will not see with SDR, like standard dynamic range TVs. Okay, I think that's it. Again, if you think of another question later on, feel free to send us a message on Instagram or Facebook or by email, or just like the classic way, give us a call next week. That also works. And Oh, another one. Okay. How would you describe your brand look? We tried to create something new in a way. One thing that we really liked was about the size master anamorphics was that you could use them like the whole field. You can just use them like a spherical lens. You don't have to worry about the actor or actress's face getting distorted. So that's something that we really like. We wanted to keep that aspect, but for us it looked a little bit too not anamorphic enough. So we wanted to have all the cylindrical lens elements in front of the iris to give this classic anamorphic look. And something that we really enjoy about all vintage lenses, both anamorphic and spherical, is this bokeh that's not cut off. So we try to find a blend between vintage, pleasing aesthetic, but with all the positive aspects of modern lens design. And compared to other brands, I think it's like we tried to find something new that hasn't been done before.
Can you guys talk about how's it going over there with COVID? I hear that Germany's loosening up a bit.
Yes, fortunately. So we only had small delays with the manufacturing so far in the design. One of our designers had to go for a short time into isolation because she was in a high risk area, but fortunately nothing happened. Yeah, so for the last couple of weeks we were in lockdown, which basically we stayed most of the time in the office, and people still went to work, but most most companies switched to home office. Schools were closed, universities were closed, bars obviously were closed, are still closed. And now since this week, I think, last week and this week, more and more stores are allowed to open up again. We have, I think bars will remain closed for the next weeks. But since Germany is a federal state, similar to the US, every part of Germany will handle the next weeks and months slightly different. So some parts of Germany might open up restaurants or pubs as long as they have an outside seating area. Others will remain in more strict lockdown. And of course, we're testing quite a lot. So as soon as there's an uptick again in new COVID cases, restrictions will be reimposed probably. But so far it seems to be going well. I had, unfortunately, earlier this week, I wasn't feeling so well, so my doctor sent me for testing, and I went to a local testing facility. It's a huge place, and no one was there. It was like literally the only one. We're quite surprised that someone showed up. So right now we basically don't have any new cases here in our area. And I do hope that in the US, when we're reading the daily numbers for several European countries, but of course also the US, and yeah, we're wishing everyone there all the best, especially in New York. New York was hit so hard, so we really hope that it will recover soon.
Is there any production going on right now with in Germany?
Some.
So we got a lot of feedback for the event tonight. So several DOPs were saying, yeah, I would love to join you, but actually I have a shoot. So that was good news. So it was from Switzerland and Germany mostly. So there are people working and they are having jobs, but yeah, it's still limited. So some daily soaps are being produced within very strict regulations, and then some live streaming events and yeah, interviews.
Smaller productions, maybe. Basically, as soon as you have a larger crew of catering and so on, it becomes more complicated.
Yeah. So I heard that in some daily soaps in Germany, the actors have to do their hair and makeup themselves. So the hair and makeup artist is standing there and telling them what to do. But I haven't seen it myself. It was just in the news. I thought it was quite funny, but yeah.
So they're still planning to start shooting again, but So probably not in May, but I think like no one knows really when regular production will resume, but it's probably going to be around June, July, something like this in Germany.
Yeah, someone asked if we would share the recording, and yeah, so maybe we will edit it a bit just to shorten it, but I think
we will provide the file to Michael, and when Michael will wants to share the Lens Summit files, the videos, of course, he can. We recorded the session.
Yeah, hopefully we'll be posting these events on our YouTube channel. And a link from our lenssummit.com website that people can check out the schedule on as well. It's just another thing to do, but I'm semi-retired right now, so it's okay.
There was another question. If we do clip-on diopters similar to the macro looks or the new Leica Bites macros, probably not. I mean, yes, for example, the existing Leica, I think they're called. No, that's like the new ones, the one with 140 millimeter diameter.
I think they're still macro looks.
They're wonderful. I mean, you can use those Leica diopters with our lens. We tested it, like Leica provided the first batch of those diopters to us for an event. They work perfectly fine. I mean, I'm not going to say that we're never ever going to do it, but not in the next foreseeable future, because those diopters they're quite, I wouldn't say extremely complicated, but it's quite difficult to manufacture them. It's like lots and lots of glass, and when you see the price, I think they're a couple of €1,000. It sounds quite expensive, but if you contact a lens like a manufacturer to manufacture high quality glass in a certain precision, you understand why the price is so high. Okay, so again,
so
thanks.
It's 4 o'clock in Germany.
Yeah, it's now 8:30. We're going to celebrate the event with the beer. I hope all of you can join us, the ones in Europe now, the ones in the US in a couple of hours. And yeah, it was a great event again. Michael, thank you so much.
You bet. Thanks so much for hosting it.
And I hope it wasn't too technical. There was lots and lots of technical data in the presentation, but I hope it was interesting for you.
It makes us feel smarter.
Wonderful. Okay,
So
talk to you soon.
Have a nice day, evening,
All
weekend.
right.
See you soon.
Bye-bye.
Bye.